Okay, lecture 48, collecting gases over water. Now, this is done in the lab quite a bit because it's a great way of collecting gases. They're bubbled through water into a container that's filled with water. And the hydrogen then displaces some of the water, and as long as the container also has volume measurements on it, you can instantly find out what the volume of the hydrogen gas is. So we'll know the volume, we know the temperature. That's easy enough to find out, just a thermometer will do. Now the pressure, it has to be just of the hydrogen though, so that's the problem. The total pressure is easy to find because the total pressure has to be equal to the barometric pressure. So the pressure inside the system has to be the same as outside. So if you have a barometer, you can figure out the total pressure, but inside that's equal to the partial pressure of the hydrogen plus the partial pressure of the water vapor. So we're after this. We want to find the moles of hydrogen, so we need to have just the partial pressure of hydrogen. So rearranging gives us the total pressure minus the partial pressure of water vapor. So by collecting it over water, it gives us an easy way of measuring the volume of the gas, but it introduces this guy here, this term. That's okay though, that's been tabulated for many, many, many years. And we have a small table containing a few of the temperature readings, including 21 degrees Celsius. The vapor pressure of water changes with temperature. As the temperature goes up, the water vapor pressure increases. So we have to be aware of the temperature. Now, the volume, the water vapor and the hydrogen travel around in the same volume, so we don't have to do anything to that except change it to liters. The temperature, both gases are at the same, the gas and the vapor are at the same temperature. Now we need the partial pressure of just the hydrogen if we're going to find the moles of hydrogen using the ideal gas law. So this is the total pressure minus the vapor pressure of water. Total pressure is 744. I don't change it to atmospheres because our table in our book, the vapor pressures of water are in millimeters of mercury. At 21 degrees Celsius, I get 18.7 millimeters of mercury. So we subtract this is 725. I know that offhand because I made a mistake. I ran out of room on the first try of this problem. And then we can convert this over to atmospheres. So this is 0.954 atmospheres. So we have everything here now. So the N value, we could put N sub H2 to indicate that moles of hydrogen are equal to the partial pressure of the hydrogen times the volume over RT. Note we don't have to put the volume of hydrogen because that's just the total volume. The gases are free to roam around, both gases are free to roam around in that volume. We don't have to put temperature of hydrogen. You could, there's no reason you can't, but the temperature of the hydrogen is also the temperature of the water vapor, also the temperature of everything else in the room. So the partial pressure is let me double check that. Yeah, seemed a bit high, but that's what it is. The volume is 0.0456 liters, 0.0821 liters atmospheres per kmol for R, and then the temperature is 294 Kelvin. Carrying those units through allows you to get rid of everything that's cancel all the units except for moles. Should come up to be moles. Let's see what we have here. And this comes up to be 0.008 or 180 moles of hydrogen. Now there's two questions. They want to know not the moles of hydrogen, they want to know the mass of hydrogen. So we have to convert that to grams. And 1 mole of hydrogen gas, H2, is going to be 2 grams. If you want to use 2.02, that's fine. Going to come up with either after rounding the exact same answers that I do or just slightly different. And I just want to double check. Oops. I was just thinking ahead to the other problem. I want to make sure that I have everything the way it should be. Okay, and then they want to know the mass of magnesium collected. Very, very common, classic problem. Once you've determined the moles of hydrogen, you want to convert it to the mass of magnesium using this equation. So we just, now it's a chapter 3 problem again. It'd be like if you were given this value, using that equation to find the mass of magnesium. So 1 mole of hydrogen gas is produced when 1 mole of magnesium reacts. 1 mole of magnesium, put in the 3 significant figures because now we're dealing with something that is not an exact number. Just double check that. Yep, and sure it's on the page. 0.0018 times 24.3, and we end up with 0.0437 grams of magnesium. Now normally I do more than one of these problems, but this is the classic one. Really, very little else that you can do here. You might change this. Oops. Might change this this metal. You might change this acid, but it really usually comes down to hydrogen. But if whatever gas it is, you'll be given the total pressure, subtract off the vapor pressure, and it'll give you that clue. It's like gas collected over water. As soon as you see that, that means that you're going to have to subtract off a value off of a table. And you have to be given that table. No one's going to memorize that. And that is the deal.